Okay, I am going to start with problem number 49, and this video I should be able to get through, let's say I'm going to try to get to 59 before I cut it off. That gives you a couple of different categories of problems, namely scientific notation and addition of polynomials. All right, so here we go. This says Jonas has a music player with 80 gigabytes of memory. And then it tells us 80 gigabytes is approximately this many bytes, 8 times 10 to the 10th. Each song requires an average of 2 megabytes, which is 2 times 10 to the 6 bytes. How many songs can Jonas store on the device, right? The answer in scientific notation. Okay, so we have a device that has a certain amount of space, and we want to know how many songs can be stored in there, and we're told how much space each song takes up. So really all you got to do, if you think about it, you take the total space, maybe I should say total space available, and then divide it by the space each song takes. Takes up, even though that seems wrong. That's all you have to do, right? Total space, 8 times 10 to the 10th. Space per song, 2 times 10 to the 6th. Okay, both of these are in bytes. We don't have to do any converting. So you just work this like any other multiplication problem, or rather any other exponent problem. We can split this up if we want. We can split this up into two fractions, right? The product of two fractions. Okay, 8 divided by 2 is 4 times, and then 10 to the 10th divided by 10 to the 6th is just 10 to the 10 minus 6, the difference of the exponents. Okay, 10 minus 6 is 4, so the answer is 4 times 10 to the 4th songs. How many songs is that, right? This is our answer, because it says this needs to be in scientific notation. So there you go, 4 times 10 to the 4th songs. But let's get a feel for how many songs that is. Well, if you write this in standard notation, you got to move the decimal from 4.0. Start with 4.0 and you move the decimal to the right 1, 2, 3, 4 places. Right now, if I erase all of this, 40,000 songs. Just FYI, that's how many songs that is, 40,000. Okay, that's 49 done. Next, number 50. Jeff's average heart rate, 65 beats per minute. First part says how many minutes are in one day. Well, how do we figure that out? Let's go one step at a time. We know there are 60 minutes, spell it correctly. Still not right. It doesn't look right. I think it is right. Yeah, minutes. 60 minutes for every hour. And we know that there are 24 hours for every day. Hang on, my recording is lagging. Here we go. 60 minutes for every hour, 24 hours in every day. If you multiply these and you treat these units like fractions, right? You treat these units like variables, rather, and they cancel for the same reason that variables on the opposite sides of the fraction bar will cancel, right? Because this means the hours cancel, and you take 60 times 24, which is 1440, and then you get minutes are left. per day. Right, you can also just think about it intuitively. 60 minutes per hour, 24 hours a day. You got to multiply those to get minutes per day. All right, 1440 over 1, but I don't need to write the over 1 anymore. This is how many minutes in a day, 1,440 minutes. Okay, how many times will Jeff's heart beat per day? Well, he has 65 beats for every 1 minute. And there are 1440 minutes for every 1 day. So for the same reason, if you multiply this through, the minutes will cancel and you'll get beats per day. So you take 65 times 1440, you get 93600, and that is beats per day. So how many times will his heart beat per day? Come on. It will beat 93,600 times per day. Seems like an awful lot. Jeff probably has high blood pressure. All right, and then I should probably put here complete answer here, 1440 minutes in a day. There. Okay, that's number 50. Next. The star Proxima Centauri is the closest star than the sun to the Earth. It is approximately 4.3 light years away. If 1 light year is approximately 5.9 times 10 to the 12th miles, how many miles is Proxima Centauri from Earth? Okay, so we have 4.3. We have the star as 4.3. Actually, let me start with the conversion factor. So 1 light year is 5.9. Let me do it the other way around. Let's say 5.9 times 10 to the 12th miles for every 1 light year. Okay, and Proxima Centauri is 4.3 light years away. Okay, so this is for every 1, I don't know, star. I guess it doesn't really matter. This unit here doesn't matter because we're going to multiply and light years are going to cancel. We're going to have miles. All right, so you take 5.9 times 10 to the 12 times 4.3. 5.9 times 10 to the 12th times 4.3. Right, this is a product. It's 3 things being multiplied together. I can rearrange the terms any way I like, even though I have a times with an operator here and times that's just by juxtaposition here. It doesn't really matter. Okay, I could also convert this to scientific notation because it is already scientific notation. If I prefer to think of it this way, 5.9 times 10 to the 12th times 4.3 times 10 to the 0, because 10 to the 0 is 1, and multiplying by 1 won't change it, and I don't want to change it. I need it to still be equivalent to 4.3. And then I can move these parts around for the same reason. This is all multiplication. I can think of this as 5.9 times 4.3, all of this, times 10 to the 12th, times 10 to the 0, 4.9 times rather 5.9 times 4.3, that's 25.37 times 10 to the 12 plus 0, right? Remember, you add the exponents together, still 12, it didn't change anything. All right, so I have 25.37 times 10 to the 12th. However, this is not scientific notation. It doesn't specify that we need to write it in scientific notation, mind you, but let's do that anyway for practice. This needs to be moved one decimal place over so that we have the decimal between the first two digits like 1, right? If we're going to move this one place over, then we have to increase this one by 1. So that when we check, we have to instead of moving this 12 places to the right, we'll have to move it 13 places to the right to get the same number. So this becomes 2.537 times 10 to the 13th miles. From Earth. And this way, I can just distribute. Actually, no, I don't distribute. I just rearrange. So I'd have 5.9 times 4.3 times 10 to the 12th. And I just do this multiplication again, 25.37 times 10 to the 12th. But then to convert it to true scientific notation, 2.537 times 10 to the 13th. Doesn't matter which way you do it, miles from Earth. Okay, how far is that? It's about 25 trillion miles, a long way. Okay, there you have it, basic stuff. Use the units to kind of tell you when you need to divide or multiply, especially for things like this particular problem that are not as obvious as something. You probably haven't really thought about Proxima Centauri a whole lot today. So to get a feel for, do I multiply or divide? It's really the question. Do I need to multiply or do I need to divide? And it's hard to know sometimes with these really big, obscure ideas. One way to do that is just use the units. You just set them up consistently and then think about what cancels when you multiply, then that will help you. Okay, next up, 52 and 53. Write the number in scientific notation. We're just going to cover all. Remember, scientific notation, you always want some number between 1 and 10, not including 10, times 10 to a power. That boils down to always moving the decimal place to be in between the first two non-zero digits. And then just see how many decimal places you have to move, or how many places you have to move the decimal each to the right or left, and that tells you what the power is on 10. That's the utility of scientific notation. Okay, so this is going to be 6.43 times 10 to the something. The question is, what is that something? Well, to get from here to here, we have to move the decimal place 1, 2, 3, 4, 5, 6. We have to move it to the left to get there. So in this direction, we'll have to move it back to the right to get where we started. So this will be times 10 to the positive 6. If you complete this multiplication, you should get this number. Okay, likewise, the next one will be 6.43 again, but this time it'll be times 10 to the second because I only have to move it 2 decimal places to the right to get my original number. The last one will again be 6.43 times 10, but now it's the other direction because now I have to move the decimal place 1, 2, 3, 4, 5, 6 to the right. So to get from here to here, so to go backwards, to get from here to here, I'm going to have to move it to the left 6 places. So negative 6 will be my exponent on 10. You can always check if I do this multiplication, do I get this number? And you should. Okay, likewise, number 53. Part A, this will be 2.46 times 10 to the second. This will be 2.46 times 10 to the, let's see, 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the negative 8. And this will be the last one will be again 2.46. But this time times 10 to the, let's see, we're going to have to move it 1, 2, 3, 4, 5, 6, 7, 8. So this will be positive 8. Right? You can always check by going in the other direction, right? If I do this multiplication, do I get this number? Now will tell you if you used the wrong sign on the exponent, positive or negative. Okay, that's 52 and 53. Next, we have 54. Says, I'd rather both of these just say add, right? We're just going to add some polynomials. The nice thing about adding polynomials is I can just drop the parentheses because the plus, I mean, you can think of it as distributing the plus like we distribute the negative, but it does not change any of these signs. So in the end, it's just like rewriting all of this with no parentheses. Plus negative 4x cubed, that's minus 4x cubed plus x squared minus 3x. Now I have to combine the like terms so I can actually put them together. Remember, like terms have the same variables to the same power. Both of those have to be true. So this will be 5x cubed minus 4x cubed. And then it will be plus x squared. And then it will be minus 9x minus 3x. And then it'll be minus 6. All right, so I can combine some of these, but notice some of these others don't have a matching term. This one doesn't have a matching, no, it does. This one doesn't have a matching term, right? There's no constant term in the second polynomial. Likewise, this one has x squared, this one does not. There's no matching term in the first one. That's okay, you can still add these together, right? I think of it as a 0x squared here and as a plus 0 in the other one, and then they all match. Okay, so 5x cubed minus 4x cubed, that is just 1x cubed. Plus x squared minus 9x minus 3x, that's minus 12x, and then minus 6 again. This is it. That's all there is to it. Not so bad. Again, notice the ones that didn't have a match, they remain unchanged because I really just added 0 to them. Okay, number 55, same thing, but with some fractions and decimals, but the process doesn't change. This will be negative 6.3 to the fourth minus 3 halves t minus 9 fourths, and then plus 3.3 t to the fourth plus 5 halves t plus 7 fourths. Now let's rearrange so the like terms are together. So I get negative 6.3 t to the fourth plus 3.3 t to the fourth. And then I have minus 3 halves t plus 5 halves t, and then a minus 9 fourths plus 7 fourths. All these have matching terms. That's nice. Okay, so I just add negative 6.3 plus 3.3. That should be negative 3 t to the fourth, if I'm not mistaken. And then 3 halves and 5 halves is 8 halves. So this is negative 3 halves plus 5 halves. So it's 5 halves minus 3 halves. So that's 2 halves, which is just 1. So plus 1t, or just t. And then minus 9 fourths plus 7 fourths. That's negative 2 fourths, which is the same as negative 1/2. So I believe that's it. That's all there is to it. Just carry the denominators like units. So, okay. 54, 55 done. 56 and 57, more of the same. 56 really. Again, addition, again, you can think of it as without the parentheses. Minus 3 plus 5x cubed plus 4x plus 6. Collect the like terms, so that's going to be negative 8x cubed plus 5x cubed, and you can have minus 7x plus 4x, and you have minus 3 plus 6. So negative 8 and 5, that's negative 3, and then carry the x cubed along. Negative 7 and 4, that's negative 3, but this time x, and then negative 3 and 6 is positive 3. That's it. That's it. We just added them together. This is the polynomial we get. Okay, 57 starts a new idea, subtraction, but it's very, very similar, right? We're just going to add, we're going to change this into addition so that it's like everything else that we've done, these last few examples. But in order to do that, we have to distribute the negative, which is the same as add, which really means the same as adding the opposite of all of these, right? That is the same thing. So it's just a matter of how you prefer to think about it. For me, just distributing is how I prefer to think about it. So 5xy cubed plus 6x squared y minus 4x plus 8. The first polynomial obviously doesn't change. Minus 2xy cubed, now plus 6xy plus 7x plus 3. Combine, or rather, let's collect the like terms. So I have negative 5xy squared minus 2x, that's cubed, not squared. 2x, this is cubed, 2xy cubed, and now the next one will be 6x squared y. Notice it doesn't have a companion and matching term. This one is close, but not the same. It has to have the same variables to the same power. And so the next one actually is 6xy, but these will not combine for the reason I just explained. And then we'll have what, negative 4x plus 7x, and then plus 3. Make sure I didn't miss any. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm missing one. What did I miss? Oh, this plus 8. So I have a plus 8 and a plus 3. There we go. Okay, so now I can combine these two. So negative 5 minus 2, that's negative 7, and then x, y cubed. Done. 6x squared y, 6xy, those don't combine. So I just leave them alone. I carry them through. Negative 4x and 7x, that is positive 3x. And 8 and 3 is positive 11. And that's it. That's it. It's really just addition, subtraction of the coefficients when you get right down to it. All right, last two in this video, more subtraction. More of the same idea. I'm just going to distribute the negative to all of these terms in the second polynomial because I'm adding the opposite. So 7x cubed plus 6x to the fifth minus 1 minus 5x to the fourth. Now I'll have plus 5 plus 3x to the fourth minus 4x to the fifth minus 4x cubed. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Make sure I didn't miss any terms. Okay, let's move the like terms together. I noticed these weren't in descending order, and I think in class I was switching them to descending order first, but it's not necessary. And to save some space here, I just went ahead and went right into changing sign, collecting like terms. All right, so I'm going to put 7x cubed. Actually, here I will. So in the end, it's in descending order. So I'm going to put 6x to the fifth minus 4x to the fifth together. And then I'll have minus 5x to the fourth plus 3x to the fourth together. And then 7x cubed minus 4x cubed together. And then let's see, minus 1 and a minus 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right, now we'll just add and subtract the coefficients, carry the variables. So I have 6 minus 4, that's 2. X to the fifth, negative 5 and 3, that's negative 2. X to the fourth. 7 minus 4, that's positive 3. X to the third, and negative 1 minus 5 is negative 6. No sweat. Okay, last one, same thing. Distribute the negative here, here, and here. So negative 5/7 x to the fifth plus 1/3 x squared plus 2/3, then minus 6/7 x to the fifth minus 5/6 x squared plus 2/3. All right, let's move the like terms together. So I get negative 5/7 x to the fifth minus 6/7 x to the fifth. And then I have plus 1/3 x squared minus 5/6 x squared. And then I have plus 2/3 plus 2/3 again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. All right, now let's put it all together. So negative 5/7 and 6/7. That is negative 5 minus 6. and then carry the denominator. So I have negative 11 sevenths x to the fifth, right? I'm going to carry the denominators, carry the variables. Really, all I need to worry about is this minus 5, minus 6. Okay, 1/3 and minus 5, 6. Well, I can't add those. I can't subtract those just yet. I have to have common denominators. Looks like 6 will be the best candidate. So I multiply this by 2 over 2. In other words, 1/3 is how many 6? 1/3 is 2 sixths. And 2 6 minus 5 6 is, I really just think about it as 2 minus 5, which is negative 3 sixths x squared. And then 2/3 and 2/3 is 4/3. Right, but this 3 6 reduces. So my actual final answer minus 1/2 x squared plus 4/3. I believe we did this one in class actually. So yeah, those fractions I know are always a hang up for everybody, but really you just have to practice. You have to get used to being able to change this to sixths. Right? This is, you get to multiply by 2 over 2, so this becomes 2 6. 2 minus 5, negative 3 6, which reduces to negative 1/2. I mean, you just have to get comfortable with that. All right, that's it for this one.